So let's take a look into the Suspense view built-in component. First of all, a warning. It says this is an experimental feature. Suspense is an experimental feature. It is not guaranteed to reach stable status, and the API may change before it does. Alright, so use with care or don't use. And let's see what it is. Suspense is a built-in component for orchestrating async dependencies in a component tree. It can render a loading state while waiting for multiple nested async dependencies down the component tree to be resolved. Async dependencies. To explain the problem Suspense is trying to solve and how it interacts with these async dependencies, let's imagine a component hierarchy like the following. We have a Suspense component, inside of it a dashboard child, then a profile with a friend status and a content with activity feeds and stats. And this component is it has an async setup. This is an async component and this is an async component. In the component tree, there are multiple nested components whose rendering depends on some async resource to be resolved first. Without Suspense, each of them will need to handle its own loading, error, and loaded states. In the worst case scenario, we may see 3 loading spinners on the page with content displayed at different times. That's the worst case scenario? That doesn't even sound so terrible to me. Well, anyway, let's continue. The Suspense component gives us, the worst case scenario for me, sorry, would be if we saw nothing while the whole data is loading. We just saw some blank page or some page, like we wouldn't even see any loading spinner at all. That would be the worst case scenario for me. So the user would think the page has hanged. The Suspense component gives us the ability to display top-level loading error states while we wait on these nested async dependencies to be resolved. There are 2 types of async dependencies that Suspense can wait on. Components with an async setup hook. This includes components with script setup with top-level await expressions. Alright? And then async components. And when we're talking about async components, oh yeah, I remember we have this defined async component which returns an async component, which is imported like this, and then it's used, I think it's just used normally, right? And we have some properties that I don't care about. Well, okay, async components are a thing. Async components are resolved after this promise is resolved, basically, something like that. But it takes time, so it's async. So, async components. Async setup. A composition API component setup hook may be async, like so, and then it awaits for some fetch and some rest.json. If using script setup, the presence of top-level await expressions automatically makes the component an async dependency. So if we have a script setup and we have a top-level await, it automatically becomes an async setup. Async components. Async components are suspensible by default. This means that if it has a suspense in the parent chain, it will be treated as an async dependency of that suspense. In this case, the loading state will be controlled by the suspense, and the component's own loading error, delay, and timeout options will be ignored. The async component can opt out of suspense control and let the component always control its own loading state by specifying suspensible false in its options. So we are talking about the async component, which takes some options, and it's probably has some API. Let's take a look. Async. There you go. That's the API for the async component, for the define async component function. And one of the options is suspensible, which is a boolean and it's optional. So if we set suspensible to true, the loading handler by suspense will be ignored, instead falling back to how the async component handles it. Loading state. The suspense component has two slots, default and fallback. Both slots only allow for one immediate child node. The node in the default slot is shown if possible. If not, the node in the fallback slot will be shown instead. Wait. So what are they actually? Suspense, it has a dashboard, that would be the default slot, and it has a fallback slot with loading. Component with nested async dependencies, loading state. Okay, so the fallback is the loading state. On initial render, Suspense will render its default slot content in memory. If any async dependencies are encountered during the process, it will enter a pending state. During the pending state, the fallback content will be displayed. When all encountered async dependencies have been resolved, Suspense enters a resolved state and the resolved default slot content is displayed. If no async dependencies were encountered during the initial render, Suspense will directly go into a resolved state. Once in a resolved state, Suspense will only revert to a pending state if the root node of the default slot is replaced. New async dependencies nested deeper in the tree will not cause the Suspense to revert to a pending state. When a revert happens, fallback content will not be immediately displayed. Instead, Suspense will display the previous default content while waiting for the new content and its async dependencies to be resolved. This behavior can be configured with the timeout prop Suspense, which Suspense will switch to fallback content if it takes longer than timeout to render the new default content. A timeout value of 0 will cause the fallback content to be displayed immediately when default content is replaced. So fallback content will not be immediately displayed. Suspense will display the previous default content while waiting for the new content. And then there is a timeout prop in Suspense, which is the time it takes for the Suspense to switch to fallback content if it takes longer than timeout to render the default content. So if the new default content takes longer than timeout, then the fallback content will be shown. That is very nice. That is actually very nice, because imagine the case where we click on click on a button that calls for some new async content wrapped in our Suspense, and let's say we have a timeout of half a second. Which is maybe less than the time it would take the user to think, nothing is happening here, what is happening? If we set the timeout very long, then the previous content will remain there until the new content is fetched. And if it takes like, I don't know, 2 seconds, 3 seconds, the user will be wondering like, did something even happen after clicking the button? So the solution would be, or one solution would be to immediately show a spinner, a loading state. but if the time it gets to fetch the new content is, let's say, half a second or less, then there is no point in showing a loading state because it's so fast that the user will not even be bothered. So that's a very nice feature. Events. The suspense component emits 3 events: pending, resolved, and fallback. The pending events occurs when entering a pending state. The resolve event is emitted when new content has finished resolving the default slot, and the fallback event is fired when the contents of the fallback slot are shown. The events could be used, for example, to show a loading indicator in front of the old DOM while new components are loading. Alright, exactly. Error handling. Suspense currently does not provide error handling via the component itself. However, you can use the error capture option or the onError capture hook to capture and handle async errors in the parent component of Suspense. That's a pity that it doesn't handle errors. Combining with other components. It is common to want to use Suspense in combination with the transition and keep alive components. The nesting order of these components is important to get them all working correctly. In addition, these components are often used in conjunction with the router view component from view router. The following example shows how to nest these components so that they all behave as expected. For simpler combinations, you can remove the components that you don't need. So we have the order here would be a router view, then we have a template, then we have the transition, then the keep alive, and then lastly the suspense. I mean, sure, fine. Router view, transition, then keep alive, then suspense. Yeah, we don't care about keeping alive the transition, right? But we care about keeping alive the state of the suspense. The router view is just, the URL. We go to a URL that renders a specific router view. View router has built-in support for lazy loading components using dynamic imports. These are distinct from async components and currently they will not trigger suspense. However, they can still have async components as descendants and those can trigger suspense in the usual way. Alright, so far so good. We are done with the built-in components. Next is going to be scaling up. But that would be for the next video. Thanks for watching. See you around.